Welcome to the DAFNI introduction. DAFNI is the Data and Analytics Facility for National Infrastructure. So it's all about infrastructure. When you do maps and stuff, like you want to look at a region and you want to explore resilience, for example, in a particular region of with respect to flooding or climate change or whatever it is you happen to be looking at, how people are getting around, transportation and stuff, then DAFNI is the place for you to go. And when you log into DAFNI, this is what it looks like. So you have obviously the home screen where the release notes. At some point soon, we will have sort of advertisements from different projects using DAFNI, where you can find out what they're doing and what the kinds of things, the outcomes, the models, the things that they can share with you. There's a section on data which builds on our own data repository, although we also have features that are not available at the moment, but we have features to make external data sets available as well. So the idea is if I search for the urban observatories, for example, then I can find the data associated with usually Newcastle's urban observatory. And then they will have some data sets, and you can see the metadata that they have entered, and you can see the region that they are talking about. And then I can actually download the data if I wanted to have a closer look. But ordinarily, I wouldn't download the data. I would just use it directly inside of DAFNI. So because we're looking at resilience of national infrastructure, what we're really trying to target is the person who is a domain expert rather than a computing expert. So if I go to one of our HPC systems, and I'm logged in to our HPC system, as you can see, this is not particularly user-friendly. If I don't know what I'm doing, I would feel at a loss for getting anything done on this system. So the idea in DAFNI is that you can be an urban planning expert or pollution or air quality expert or demographics or supply chain resilience or whatever expertise you have. You don't have to learn command line. You come to DAFNI with your applications and it sits within DAFNI and will be easy enough to use by somebody who doesn't want to learn command line stuff. So once you have the data, we also need to process the data, and those are done in models. And Kyle will show you shortly what models actually look like. So a model, for example, will have some metadata with it as well, and which input parameters it expects, and what sort of input files it expects, and what sort of output files it will produce. So whenever you run a model, you will make sure that it has the data. It either uses the default data set that is provided by the model owner, or you can supply your own as well. And normally you will probably supply your own because you might be interested in a different region than what the original model was designed to work with. And then we get to the workflows, which Kyle will show you shortly. The workflow, when you do a workflow, you can see what it actually looks like. This one will give me error messages because I don't have permissions to see the whole workflow because the usage is a little bit restricted. But I can still see what the workflow looks like, and I can ask for permissions to use it if it's something. This one, for example, is looking at flooding, I think, but its use is restricted by its license. So I can see the workflow, but I won't have permissions to run it without asking for permissions. They're fairly simple workflows in the ones I've managed to dig out here. But you can also do more complicated things like chaining things together and stuff. And I could put my own workflow together if I want to, by basically doing a start, and then I can set up loops. Oops. Set up a loop, and I can set up parameter sweeps where it runs a model through a certain set of parameters, and just by dragging and dropping them together and Okay, maybe I didn't want that one. I want a model probably here. And maybe I want the output to feed into that one. And eventually, maybe I want to either publish or I want to publish and visualize the outcome. And maybe there's sort of like a joint data processing there that I want to put together. Now, this workflow looks very anonymous because I haven't actually specified what's in each of the models. So if I want to actually build one that works, I need to select a model that I want to put into my workflow. And for each of those, I will need to give it data sets and stuff as well. So in the loop, the workflow, obviously the output of one model should match the input expected of the next model, so that it will actually run in sequence and eventually generate a visualization at the other end. So with that, for example, if I wanted to take a data set, I would make note of the dataset ID, dataset ID, and then I would put that into my workflow and say this is the input to a particular model, and it'll run the workflow and it'll produce an output at the other end. I can also create a visualization. For example, I would have dataset. I probably want a Jupyter notebook actually. And I want to say, well, this is just a demo, and this is a demo, and I create a visualization. And now I have created the visualization, and it will take a moment for it to start up because it actually starts up on the workflow engine as well. And then I can click it. And unsurprisingly, you see a Jupyter notebook. And we have demonstrations of them. So we have example models and stuff that Kyle has put together, most of these, where there are Jupyter notebooks that are built into models, or they run as standalone visualizations that people explore their data sets or show the outcome of data sets. So that was the basic quick introduction to DAFNI. With the projects that we support, they will often form groups. So there will be a group that you're a member of. So I'm a member of a couple of groups, and there will also be stuff that is really just public where anybody can come in and use it as long as they have a DAFNI account. There is a certain level of assurance that you need to have to get into DAFNI. So for most people, we will assume they have a grant or they have a project that they're working with us. And then we will give them an account on DAFNI. And so then by default, the stuff you may have in a group is private. This one, for example, is a spreadsheet which was used for a demonstrator. A dirty spreadsheet is one where the calculation is not up to date. It has had a change made to it before, but without recalculating the spreadsheet. So the demonstrator was to use an Excel spreadsheet within a workflow and have an automated step that updates and recalculates the spreadsheet whenever a change is made. So that's something that is not shared because it's less useful for other people. But it's something that climate modeling, so things we can share with so there's a private group, but whenever we decide to make things public, then they will appear here, and people, oh, it is actually here. It is actually shared if people wanted to have a look. So I think that's it for the introduction to DAFNI. Kyle, in a minute, will give you an actual demo or some real work on DAFNI. Are there any questions? So it sounds like there are no questions. So over to you, Kyle.
Hello. So I'm going to continue from Jens now and basically just show you some models. These are mostly ones we use for training, and just going to basically go through how they're constructed and also go through visualizations at the end. So we'll also show you a visualization from an EU project, which will probably be of interest to you too, and a sort of prototype of a digital twin that we've got. Okay, so I'm going to hopefully successfully share my screen now. That's right. So the first thing, I'm going to try and locate my browser. Okay, so I'm logged in. So I'm currently logged in one of the training accounts I've got in DAFNI actually, and this is basically just to show you the layout and go through a model. And it's quite a straightforward model. This one, it just models a solar panel. So photovoltaic panel, and just models and estimates the energy that should be output from it. The digital twin sort of takes it a little bit further, and I'll show you that as well. So first of all, I think, so data I think is pretty self-explanatory. Jens explained the models and how we build workflows out of the models. So now sort of like as they used to do, and probably still do in Blue Peter, go to one that's been made already so that you can see how this all plugs together. So the first one I'm going to do, I'm going to make sure I'm going to actually pick the demo ones because this, as I mentioned, this is a training account. So this is why it's repeated lots of times. And some of them I can guarantee will not actually work because they haven't been finished properly because they're from training sessions. So I'm going to pick the one which I specifically know does. Okay, so as Jens mentioned, this is what a workflow looks like. So essentially, just to recap, this is the model. And this calculates, you basically, you give it a set of coordinates, give it an altitude, and it works out the solar power that's instant on a panel, basically a plane at an angle to the Earth. It does that, generates some data. The data can be set, as I'll show you that in the later little bit. And then it just publishes the output. For this case, it's just a simple time series JSON file. And we'll show you how that sort of runs and comes about. Okay, so if I go back to the workflow itself, you can see here we've got different input parameter sets, and this is basically how you can run the model in different modes. So if I go here, I'm going to left click on it, and essentially what it's doing is it's firing up a Python script, and the Python script takes longitude and latitude. I think this is somewhere in, actually I think it's Cairo Airport, this one. So that's just the default set. Minus 999 means get it from a height map rather than sort of put it in by hand. And this is just the positioning of a solar panel, and basically the spread of dates you want to generate data from. So that's essentially it. This is basically loaded into a Docker container and then saved to DAFNI, and then it should be flexible and usable from there on in. So if I go back here, I'll just very quickly actually go through this one as well. Actually, I think we've got a fair amount of time, so I don't need to worry about spending too long in each particular bit. So yeah, so it's basically just the same as before, different coordinate set. And this is now ready to go. So I believe there's actually a public version of this as well. So it should be hopefully accessible to everyone. And then if I could just go in here, I'm not actually going to execute it because it would take like 5 minutes and we'd just be sort of waiting for 5 minutes, which is not ideal, but I'll just show you how we'd start run. That's now off and running. If I go down there, you can see it's starting to load in. Basically, that means it's been allocated to a particular node in their server. So yeah, the hardware, the actual silicon that is DAFNI at the moment. So that'll go off and it will run. Yeah, you can see it started running already. It actually is fairly quick. It doesn't take long at all, but I will cancel it because we've already done that and we don't need to rerun it. Okay, so starting runs is as simple as that. So this is only running, of course, for one set of parameters. I'll very quickly show you a version which runs over multiple parameters and how that works. But before we go there, what I'm going to do is go to visualization. So if we go to one that's been done before. I'm going to just pick that one. There seems to be two of them from that date, but don't know why. But you can see now it gives some details there. In this case, it really just tells you what the parameter set it ran with was, and that it succeeded. It's okay. Clicking in the publish stage. I think Jens actually showed you this. So basically you can download it and it's good to go. What I'm going to do is go to visualization. So the visualization essentially links to this data set and instantly grabs it. And if I'm right, that was yeah, that should be it. Okay, and that should load in. And as Jens mentioned, in DAFNI, our visualizations tend to come in different flavors. And this is the Jupyter Notebook flavor. So this is requires a bit of coding for Jupyter Notebooks. The CSV drag and drop one doesn't require coding, but it is a bit more limited and it does need CSVs. So in general, for flexibility, this one is generally the way to go. And hopefully if I run this, it should grab the data which is included in this folder here. That's essentially the raw data that's produced by that Python model. And you can see that the power incident peaks up as we go through the date, which is in a form of a timestamp. That looks like the number of seconds since 1970 or whatever. It's a date format used in computing. Okay, so it's loaded the data, the first part there. And as Jens mentioned, these are all on our web page as well. So essentially all we're doing here is we're just using a Python package to plot the data that's in that JSON file. So it's actually pretty straightforward. Hopefully, yeah, all of this is just basically formatting mostly. And this just shows the average and the limits for the power that's instant over the day. Okay, and yeah, and that is essentially how you'd run a model in DAFNI, how you would look at the data using a particular form of the visualizations. There are sort of variations in this. So if I go back here, we go to the workflows again. There's another one which is basically based in this one. And let's see, go down to these ones as well. I feel I should make an account which isn't actually our training account for this because it does tend to fill up with our various training sessions and tests and whatnot. Okay, so yeah, so this is the other one, and Jens actually showed a workflow that had these elements in as well. And essentially, what this is, instead of running the model once, it runs it multiple times with different parameters set up. So if we go back and we look at the parameter sets, you can see it's very different from the previous one. Well, not very different, slightly different. And this here is basically the direction in which the solar panel is pointing. So instead of just using one direction, it basically varies which direction they're pointing in. And essentially this one's just set up to demonstrate what happens if you loop over it. So you can obviously you can loop over more than 4 elements. I think we have parameter sweeps which are specifically designed to run up to 1,000 different parameter sets. Okay, and again, the data that's output is 4 data sets this time, rather than 1 because it's in a loop. And if we go back to the visualizations again, hopefully it's in the, oh, not that one. Where is it? There. Okay, and yeah, actually I've already run it. You can see it's basically similar to before, except it's power rather than irradiance. And it's for the car park here at STFC. Not in the office at the moment, but normally it's just like a quick walk away.
Yeah, we're interested in that because we have solar panels all over site. So most of the roofs well, many of the roofs have solar panels on them now, and a car park.
Okay, so that's essentially a sort of a quick intro to how it works. Another visualization. This is basically just to demonstrate Plotly, which is different, and hopefully, yep, that's all run. And that just basically shows them shipping that was sunk in World War II. And it's essentially just to give a sort of demonstration of how you would use Plotly to generate graphs. There's other ways to do it as well. I can show you another project, one that's recently come to a conclusion, and they've done this slightly differently. And yeah, there we go. So it's essentially an example of how to do various forms of maps. I think Folium's the other one that people tend to use as well. Okay, so that's sort of a broad overview. Another thing is, let's see. So actually, I'll show this first. So this is essentially a digital twin. It's not running in a high frequency, so it essentially runs every morning. And these are various sites in the UK, solar panel sites. This comes essentially it's taken directly off the government database, the coordinates and the power outputs. And what you can see here is data. Now the data is for one specific region because it actually turns out to be really hard to get live data feeds from individual solar panel sites. So we've just set it up as a test case, and that's essentially just data from one part. It's just sensors that are part of the UK Urban Observatory program, which ran several years ago, and they've got sensors to do the solar power. So if you click on that and then it'll update, it'll give an estimate, and that's based on future weather projections from the European medium range forecasts. And it's not finished at the moment, this as well, so I should point out. It takes a little while to update because of that. Currently we're optimizing the database, but yeah, it's still functional, up to date, and these are predictions using the solar model, taking cloud cover into account as well. Okay, so a more sophisticated visualization, and this is actually built into DAFNI itself now. This is for a cross-EU project, and you can see that this is their visualization, really nice visualization. But this basically gives us an overview of the temperature. Also, I believe that's is that wind? Yeah, so wind speed. Precipitation and air quality as well. And this is for the entire world. And this is the initial sort of prototype of the browser. So this browser will ultimately take data directly from DAFNI. So at the moment, it's just got one data set, but in the future, people will be able to select multiple data sets for the browser. And it should also break down into various regions as well. Yep. So the various NUT regions of the EU should load in. Okay, good. So I should point out this is an initial version as well, so that this will get updated in the future. Okay, and I think the good thing about this is people will be able to start their own visualizations. So if I go back here, we can create visualizations by, I think Jens actually showed this. So you can select some data and go through here. And that's a bit it was going to point to as well. So you can see this Jupyter drag and drop. When the TEAL tool is fully operational, it'll be possible actually to bring that up as a sort of visualization as well using different data sets. Okay, so so I should probably show I should show the last data set as well. Sorry, the last visualization type as well. So I have to warn in advance that I'm not particularly proficient with the drag and drop tool. First of all, what I'm going to do is update the spreadsheet because the first column wasn't working for some reason. So essentially, this is how you'd update a data set in DAFNI, what I'm going through now. So hopefully live repairs. That's all fine. And we're going to just hopefully fixed. And you can see it's very easy to update a data set this way in DAFNI. Hopefully this will be nice and quick. And the little triangle means it's been copied internally within the cluster in the disks. And it's a small spreadsheet, so it went really fast. So what I'm going to do now is just create visualization based on that. So we can grab that data set. That's literally that Excel spreadsheet I just put in. Add drag and drop. Get the spelling right, and hopefully that should start drag and drop one up. And hopefully this time we'll be able to plot a time series of data. If not, I can just show a correlation between two indices. Okay, and essentially it should just feed straight in. Yep, we can see that's the CSV file because I've included that. And yeah, it's got the wrong name, but we've set up the x-axis to be a time series. And if I grab one of these, productive industries index, that should do the job. There we go. So so essentially that's a time series. It's just the industrial index. And I think the time scale, so I was playing around with it in Excel and I've clearly got the dates wrong because it should be 1950 to 2025. But essentially, if the CSV file had the correct time series, that would display it. That's me. So you can also see. Let's see, is there service industries? We can add new fields as well. So there we go. There's the service industries one. We can add that one and replace it. And you can see that's just a general climb. Unfortunately, I don't know how the dates get scrambled. They've been all, yeah. I mean, that should be about 1950. And I'm guessing that's probably the COVID period. Not sure what that is. That'll have been some recession, like probably in the 80s or the 90s. Okay, so that's how you play around with the CSV. It's quite flexible. You can get different types of graphs. I'm not super proficient with the interface for doing this, but it is quite flexible and you can construct some quite nice graphs with this. Okay, so I think that's the bulk of everything. We should, hopefully I'm about at the right time for the demo. Let's see if there's anything else. So I showed the main thing was to show you the visualization here, the WMC tool, TEAL. Okay, so does anybody have any questions? I know I realize I've been talking pretty much non-stop, so it's probably a good time to ask if anybody wants to ask anything. So I should point out these. So these are just our test models and workflows. So if I go into my main account, so I'm doing this because I've got access to all the workflows this way. Unfortunately, because it's an admin account, it takes a little while longer to churn through. So this is one of our recent models. So this was work that was done by Cranfield University, and basically it works out diversions to different airports. If an airport gets closed, it'll work out the diversions for various flights to different airfields. And if I pick one of those, let's see, I think Gatwick would be a good one. If I go in here, the visualization's already set up. And as I mentioned, that you can, some of them use Folium, and this is an example of something that uses Folium. You can see the diversions for the various flights. Most of them get sent to Heathrow, just down the road, Stansted as well, and one gets sent up to Manchester. And that's an example of one of the projects that we recently had. It's a series of projects that just finished off actually within the last few weeks. Okay, so questions?
So one point to make about drag and drop perhaps is that, of course, you can do the same thing in a Jupyter notebook. It's just that a drag and drop is more accessible because you can just literally drag and drop.
Yeah, it's much easier to use from that side of things.
Yeah, it's much easier to use.
Doesn't require coding.
Yeah, exactly. Okay, if I can share my screen again, please, Kyle.
Okay.
So, so just to show a slightly more complicated workflow, this one is also equipped with a restricted license, but you can see how those things are sometimes connected together. So what do you do if you want a DAFNI account? So you go to dafni.ac.uk and you can learn more about the program, what we're doing, and the projects we're working on, and various other projects who are running stuff on DAFNI. And if and when you want to have an account, you click DAFNI login, and then it says if you already have an account on DAFNI, then you log in there. And if you do not, then we have an application form. This one just took me straight through because I obviously have a DAFNI account and I am logged in, but otherwise you'll put details of you'd say you work on UrbanAIR and your email address, and then we can set up an account. Okay, any final questions?
Okay. I should point out, if anybody wants to email us, you can reach us in the support email. You can ask questions on there if you'd like, and obviously you can go through the web page as Jens showed to get an account as well. We also have training sessions to help people get started as well. These tend to be focused in the model side of things, so uploading and running models and how to do that.
Okay, thank you for attending the session. Hope you found it useful, interesting, or something, and have a good weekend.
Thank you.
Bye-bye.
We'll be uploading the recording to the SharePoint site. Thank you.
Thank you very much.
Bye.
Thank you.